In previous session, we discussed formation of PDE by eliminating arbitrary functions of the form phi of u plus u comma v equal to 0. Now, in this session, we are going to discuss formation of PDE of the form z is equal to addition of two functions. Okay, which means see here, there is a note. If we have two arbitrary functions, to eliminate the functions, we need the second order partial derivatives also. See, up to previous, okay, means eliminating arbitrary functions of the form phi of u comma v equal to 0, up to there, we find only first order partial derivatives. Okay, but now, suppose if we have two arbitrary functions, there, to find the PDE, to form a partial differential equation, we need higher order derivatives also. Now, see this problem, z equal to y of y into f of x plus x into phi of y. Now, by data, first we should consider the given equation as 1. Now, as usual, first find out all the partial derivatives, first and second order. That is, you should find out p, q, r, s and t. So, first, find out p. P is nothing but dou z by dou x. If we differentiate equation 1, that is z is equal to y into f of x plus x into phi of y. Suppose if you p is nothing but z with respect to x. If you differentiate y into f of x, you will get y into f dash of x plus x differentiation is 1. Here x differentiation is 1 into phi of y. 1 into phi of y. Call this as equation 2. Similarly, next find out dou z by dou y, which is nothing but q, which is equal to q means we should differentiate z with respect to y only. See here, y differentiation is 1 into f of x plus x is constant here, so x into phi of y, it's a function of y, no? So if we differentiate this, we'll get its derivative, that is phi dash of y. Equation 3. Next we have p and q. Next, by using that, we can find out the second order derivatives also. Now, r is nothing but dou square z by dou x square. This means we should differentiate dou z by dou x again with respect to x. We'll get the second order derivative, which is nothing but r. See, now we just differentiate y into f dash of x plus phi of y again with respect to x. If we differentiate this, you will get, see, y right as it is because y is constant. F dash of x, its derivative is f double dash of x plus phi of y is a constant. Okay, that's why it is 0. So you'll get y into f double dash of x. Call this as 4. Next, yes, s is nothing but dou square z by dou x into dou y. See here, dou square z by dou x dou y. I already told you about this. How to write dou square z by dou x dou y? See, dou y dou x of dou z by dou y. Okay, this gives us dou square z by dou x dou y. Okay, now to find dou square z by dou x dou y, you should differentiate dou z by dou y, means this one, dou z by dou y with respect to x. Okay, to find dou square z by dou x dou y, we should differentiate dou z by dou y with respect to x. Then we'll get dou square z by dou x dou y. Okay, so now differentiate dou z by dou y with respect to x. If you differentiate this with respect to x, you will get f dash of x, its derivative, plus x derivative is, if you differentiate x, you will get 1 into phi dash of phi. Call this as equation 5. Next, dou square t is nothing but dou square z by dou y square. dou square z by dou y square, you just differentiate dou z by dou y again with respect to y. You'll get dou square z by dou y square. Let us see, f of x is constant, it will be 0 plus write x as it is into phi dash of y becomes phi double dash of y. Equation 6. Now by using all the 5 equations, we should eliminate the functions. See, to eliminate the functions, when we have two arbitrary functions, to eliminate the functions, we should consider or we should concentrate on last 3 equations, means higher order derivatives equations. Okay, by using higher order derivatives we can eliminate the functions. Okay, to eliminate the functions we can use first order derivatives equations. See, by using second and third equation, it is not possible to find f double dash of x, right? Similarly, we can't find out phi double dash of y also by using any of the equation. So that we can't use fourth and sixth equation to eliminate the function. But see here, in equation 5, f dash of x, phi dash of y. See, by using second and third equation, we can find out f dash of x and phi dash of y. After finding f dash of x and phi dash of y, we can replace in that equation. Okay, so that's why. So by using 2 and 3, see, f dash of x is p minus q of phi of y by y, and phi dash of y is q minus f of x by x. Now I am going to substitute in equation 5. See, after substituting, we'll get this equation, that is s is equal to p minus phi of y by y plus q minus f of x by x. Now simplify this by taking LCM, you'll get this equation. Now see equation 7. If we observe equation 7, xys is equal to px plus qy minus x into phi of y plus y into f of x. This is nothing but z. Okay, now this is equal to z. So in place of this, we can replace it by z. Now see, functions are eliminated. That's it. We just simplify this, we'll get xys plus z is equal to px plus qy. This is the required PDE. If you want, we can write in terms of derivatives also. Now, 10th problem. Z is equal to f of y plus x plus g of y plus 2x. Here also we have two arbitrary functions. Similarly, previous problem we can solve. So that first we should find out all the 5 derivatives. P, Q, R, S and T. Okay. After finding this, now observe equations 4, 5 and 6. Okay. In equation 4, 5 and 6, see here, if we observe this, see 4 and 5. If you use 4 and 5, by subtracting this, we can eliminate f double dash of x. Then then the remaining is in term of g double dash. Similarly, next suppose if we solve 5 and 6 by subtracting 5 and 6, here also we can eliminate f double dash derivative. Then again we'll get g double dash. Then finally we can divide. If we divide, we can eliminate all the functions. So that's why here 4 minus 5. See, here our aim is to eliminate the functions. Okay, depends on equations we can perform. 4 minus 5, this implies if you subtract 4 by 5, see, r minus s is equal to f double dash if you subtract f double dash gets cancelled. So 4 minus 2 is 2 into g double dash of y plus 2x. Similarly, if we solve these two, 5 minus 6, again f double dash, here f double dash gets cancelled. 2 g double dash minus g double dash is 1. So 1 time, that is g double dash of y plus 2x. Now observe this. You just divide 7 by 8. If we divide 7 by 8, see, if we divide these two g double dash gets cancelled. We'll get only 2. You just cross multiply this, simplify, we'll get r minus 3s plus 2t. All the functions are eliminated. If we write it in term of derivative, we'll get dou square z by dou x square, means r represents dou square z by dou x square, minus 3s represents dou square z by dou x dou y, plus 2 into t represents dou square z by dou y square. This is the required derivative. Sorry, partial differential equation. Similarly, we can solve 7th problem also. 8th one, sorry, 11th one, and now 12th one. Here same f1 of y minus 2x plus f2 of 2y minus x. By data, now first call the given equation as 1. Now find out all the 5 derivatives p, q, r and s, and t. We'll get 5 equations. Now observe 4, 5 and 6. See, if you observe this, see here 2 f double dash, the fourth one, the 4 f1 double dash, here f2 double dash, here minus 2 f1 double dash, here minus 2 f2 double dash. By multiplying something here, see, suppose if we multiply 5 by 2 into 2, if you multiply 5 by 2, then if we add 4 and 5, after multiplying 2 in 5, if we add 4 and 5, we can eliminate first term. Okay, then we can write the remaining term. Similarly, to solve 5 and 6, observe 5 and 6, here minus 2 f1 double dash, here minus 2 f2 double dash. Here f1 double dash, here 4 f2 double dash. Here suppose if we add again, multiply 2 by 6. Then if we add again, we can eliminate first terms. Okay, if we do that, see here 4 by equation 4 by 2 plus 5. We'll get this equation. And if multiply 2 by 5 plus 6, we'll get this equation. Now observe these two equations. If we divide these two, okay, again if we divide these two, easily we can eliminate. See, if we divide 7 by 8, f1 double dash, here f1 double dash gets cancelled. Here 3 ones are, 3 twos are. So we'll get 2r plus s by 2s plus t is equal to minus 2. See, here it is. Now again cross multiply this, simplify, we'll get 2r plus 5s plus 2t equal to 0. So finally write it in term of derivatives. That's it. This is the required PD. Like that we can solve 13th, 14th, 15th. The 13th one, this is eliminating arbitrary constants. This problem based on eliminating arbitrary constants. 14th one, it is of the form f of u comma v. By using chain rule we can solve. 15th one, two arbitrary functions. We have two arbitrary functions. That's it. Okay, next topic in PDE is solution of PDE. Solution of PDE. See, still previous problem we find the PDE, right? We find PDE by eliminating arbitrary constants and arbitrary functions. Now in this topic we are going to find the solution of PDE. Okay. Now let us see the definition first. See, a solution or integral of a partial differential equation is a relation between the dependent and independent variables satisfying the equation. Okay. Solution or integral of a partial differential equation is a relation between dependent and independent variables which satisfies the equation. Means given equation. That's it. Now first, in that first subtopic is solution of non-homogeneous PDE by direct integration. Solution of non-homogeneous PDE by direct integration, because you have solution of homogeneous PDE also that we can't solve by direct integration. We can solve or find solution of homogeneous non-homogeneous PDE by using direct integration. Okay. Now see, in this method we find the dependent variable, which being the solution. Okay, by removing the differential operator through the process of anti-differentiation. Anti-differentiation is nothing but integration. Okay, which means here we need to find the dependent variable value. Okay, if we in problem they will give one differential equation, that is non-homogeneous partial differential equation they will give. To find its solution, we need to the solution is nothing but the dependent variable. If you find the dependent variable value, that will be the solution. How to find dependent variable? See, suppose if you have dou u by dou x, dou u by dou x. This is the one derivative. Here, independent variable is x. Dependent variable is u. Okay, here we are finding the dependent variable. To find u, we should eliminate the derivative, that is dou by dou x. To find u, we should eliminate the dou by dou x. How to eliminate dou by dou x? If you just integrate, if we integrate it, if we integrate this derivative, integration and derivative will eliminate. This gives you only u. Okay, this is the procedure. Okay, now. So now we are going to do the same thing. Now, first problem. See, solve dou square u by dou x square is equal to x plus y. This is the non-homogeneous equation. How we can identify if the given equation is homogeneous or non-homogeneous PDE? See here, dou square, the derivative is with respect to x only. That's why in RHS also you should have function of x only. Here in RHS we have function of another variable. We have y. That's why this is non-homogeneous. Okay. Suppose if you have only dou square u by dou x square is equal to x, this is a homogeneous. Here you have plus y. Y is another variable. Here the derivative is u with respect to x only. So that's why this is non-homogeneous equation. So now to find the solution, this means here we should find out u. We should calculate u. Here u is the dependent variable. Okay. So now consider the given equation as 1. Now first you should split the derivative. Dou square u by dou x square can be written as dou by dou x of dou u by dou x. This is equal to x plus 5. Because to integrate we should write the derivatives in this form. Okay, now to find u, see here we have dou square second order derivative, so that we need to integrate twice. Suppose if we have only dou u by dou x means first order derivative, if once integration is enough. But here we have second order, right? So that we need to integrate twice. So first we should eliminate dou by dou x. If we integrate once, dou by dou x will eliminate. So that's why now integrate with respect to x, treating y as constant. This is understood because we are doing partial differentiation. Okay, now see. Integration. Take integration on both the sides with respect to x. See, integration with respect to x. Here also integration with respect to x. If we integrate this, the integration and derivative will eliminate. We'll get only dou u by dou x. That is right here. This is equal to. Now integration RHS. X integration is x square by 2 plus y integration. Y is a constant, right? Integration of constant x into y plus c. After the integration, we usually use to put plus c, right? In ordinary normal integration, after the integration, we usually used to put plus c. This is partial, no? That's why partial means if you are integrating with respect to x, you should treat y as constant. That's why in place of c, constant place, I will consider f of y. F of y is nothing but function of y. because here we are integrated with respect to x, right? So that's why function of y should be constant. This is understood. That's why here I am taking in term of function of y. Okay. Similarly, see, after once integration, again we have dou u by dou x. Now we have to eliminate dou u by dou x. To eliminate dou u by dou x means here we need to eliminate the derivative, right? That is dou by dou x. Here we should eliminate this derivative, sorry, differential operator, that is dou by dou x. To eliminate this, again we need to integrate on both the sides. See, like this integration. If we integrate this, the integration and derivative will eliminate. We'll get only u. So that write u here. Now integration. Here we should integrate complete equation. X square by 2 integration x cube x square by 2 1 by 2 into x cube by 3, that is x cube by 6 plus xy integration with respect to x we are doing with respect to x. So x square by 2 into y plus here we should integrate f of y also. We are integrating with respect to x, right? F of y is constant. That's why x into f of y. Plus again after the integration we should consider one constant. Here you take that is f g of y. Because we are differentiating with integrating with respect to x, no? That's why that constant should be function of y. So this is the required solution. Okay, this is the required solution. This is the solution of given PDE, means non-homogeneous PDE. See, in next problem, solve dou cube z by dou x square dou y is equal to cos of 2x plus 3y. Okay, this is also a non-homogeneous equation. To find z, see here z is the dependent variable. We should find out z. To find out z, first we should split the derivatives. How to split? Dou cube z by dou x square dou y. If we split this, you will get dou by dou x of into again dou by dou x of dou z by dou y. This is the way of splitting this derivative. This is equal to cos of 2x plus 3y. Now see here. Here we have three differential operators. Okay, to find z, we should eliminate dou by dou x, dou by dou x, dou by dou y. Okay, so first one, to eliminate dou by dou x, see here, we should integrate 3 times to eliminate all the derivatives. Okay, the first, we should eliminate dou by dou x, integrate once. With respect to, see here, it is with respect to x, dou by dou x, no, that's why we should integrate also with respect to x. If we integrate this, see, derivative and integral gets cancelled. We'll get only dou by dou x of dou z by dou y, which is equal to, see, integration of cos 2x plus 3y is cos integration sine of 2x plus 3y by here. See here, divided by, we are integrating with respect to x, no, 2x divided by 2. 3y 0, need not to write. Plus after the integration, we should consider a constant. Here, that constant is function of y. Now, see, again we have two more derivatives here. Now we should eliminate dou by dou x. So again integrate with respect to x. Integrate with respect to x. After integration, derivative and integral will eliminate. We'll get dou z by dou y. This one, which is equal to, see here see here, please made one correction. That half is belongs to only sine. This means this represents half is belongs to both the functions, both the terms, right? That's wrong. This half is belongs to only sine 2x plus 3y by 2. plus f of y. If we integrate this, see, sin 2x plus 3y becomes minus cos of 2x plus 3y 1 by 2 into 1 by 2, that is 1 by 4. Cos of 2x plus 3y plus, see here, f of y integration is f of y constant. If we integrate with respect to x, we will get x into f of y plus, after the integration, we should take one constant, that is g of y. Okay. After this step also we have one more derivative, that is dou z by dou y. Now we have to eliminate dou z by dou y. To eliminate this, we should integrate z with respect to y. We should integrate with respect to y. Okay. See, if we integrate with respect to y, integral and derivative will eliminate, will get only z, which is equal to. Here also please make one correction. This is not 1 minus 1 by 4 here. You just write it here. Divided by minus 4. This belongs to only this term. Okay, not for all the terms. Belongs to only first term. Plus x into f of y plus g of y into dy. The cos integration is sine. See here I took minus 1 by 4 outside. Sine 2x plus 3y. Here also please make one correction. Divided by, see here we are integrating with respect to y. No, this becomes 3. Sine 2x plus 3y by 3. Not 2. Divided by 3. Plus x into, see, what is x into? Here x is constant. We are integrating with respect to y. So x is constant. Write x as it is into integration of f of y. We don't know what is the value of f of small f of y. No. That's why integration of small f of y is written in the form of capital F of y. That's it. Plus here g of y is also a function of y, right? If we integrate this, we'll get integration g of y. So I written that as capital G of y. Plus after all the after integration, we write one constant. Here the constant is function of x because we integrated with respect to y. No, that's why here function of x is a constant, that is h of x. Here you just mention what is f of y, capital F of y and capital G of y. Capital F of y is nothing but small integration of small f of y, and capital G of y is nothing but integration of small g of y. Okay, now this is the way of finding solution of non-homogeneous PDE by direct integration. Similarly, we can solve third problem also. Here I'll give, I guess, solution for that problem. Okay. See now fourth problem. This is one of the important problem. See, solve. See, this is also similar to, it is same as previous problem. Okay, here you have some conditions. Okay, by using these conditions, we are going to find that constant values. That's it. See here we written some constant, right? Constant values. So by using those conditions, we can find out that constant values also. Now see one problem. Solve dou square z by dou x dou y is equal to sin x sin y. Okay, for which here it is the condition. Dou z by dou y is equal to minus 2 sin y when x equal to 0. And z is equal to 0 if y is an odd multiple of pi by 2. So first we should solve as previous problem. Okay, you just find out the dependent variable. Here the dependent variable is z. So here first we should find out what is z. After finding z, we can use the given conditions to find the constant values. So first find out z value. To find out z, we should use integration. The first step, which is similar to previous problem, that is first you split the derivatives. If you split, you will get dou by dou x of dou z by dou y, sin x sin y. So first integrate with respect to x. So that dou by dou x will eliminate, we'll get dou z by dou y. Integration of sin x sin y into dx. We are integrating with respect to x, right? See here sin y is constant, right? Here sin x integration is minus cos x. Plus after integration, constant term is f of y. Call this as equation 1. Now again integrate to z, to find z, again we have to integrate here with respect to y next. See, if you integrate with respect to y, we'll get z. So z is equal to integration minus cos x sin y plus f of y dy. So minus cos x into sin y integration. We are integrating with respect to y. So sin y integration minus cos y plus here small f of y is also a function of y. If you integrate this, we'll get capital F of y plus the constant is here function of x. Okay na? So now minus into minus becomes plus. This is our z. Call this as 2. We have dou z by dou y and z. Here you must and should mention what is f of y. F of y is nothing but integration of small f of y dy. Now here we have to find f of y and g of x by using the given condition. So now consider first condition. What is the first condition? Dou z by dou y equal to minus 2 sin y when x is equal to 0. To use this condition, see where we can use that condition in equation 1 or 2. In equation 1 we can use that condition because in equation 1 we have dou z by dou y. See now by data dou z by dou y is equal to minus 2 sin y when x is equal to 0. See, see in equation 1, therefore 1 becomes, in place of dou z by dou y, you just replace minus 2 sin y. That is minus 2 sin y is equal to minus sin y into, when this is when x is equal to 0. In cos x, you just replace cos 0. What is cos 0 value? Cos 0 is 1 plus f of y, right as it is. Now if you simplify this, we'll get f of y. See, keep f of y here only, shift minus sin y to LHS, it becomes minus 2 sin y plus sin y is minus sin y. This is our f of y. But according to solution, we need capital F of y, which is nothing but integration of small f of y. Already we have small f of y now, you just integrate it, you will get capital F of y. See, integration of minus sin y is minus of minus cos y. Minus into minus plus, you will get cos y. Here you don't write any constant term because we are finding constant only, right? That's why you just write cos y as it is. Now substitute f of y in equation 2 because equation 2 is the final solution, right? So f of y, in place of f of y, consider cos y plus write g of x. Now again we have to find g of y. One more constant have. To find g of y, consider the next data. See, and z equal to 0 if y is odd multiple. Odd multiple is nothing but 2n plus 1 of pi by 2 you have. So 2n plus 1 into pi by 2. See now, I consider next data, that is z equal to 0 if y equal to 2n plus 1 pi by 2. You use this condition in second equation. See, if z equal to 0 means LHS 0. Okay, LHS is equal to 0. This is equal to the cos x. Here only y, right? You just write cos x as it is. Cos of pi by 2. Cos y. Cos of pi by, no, sorry, 2n plus 1 pi by 2. Plus f of y we already have, that is also cos of 2n plus 1 pi by 2 plus g of x, right as it is. Cos of 2n plus 1 pi by 2 is nothing but 0. The cos of 2n plus 1 pi by 2 is 0. You just replace the values here, you'll get g of x. G of x is 0. Now you just substitute a capital F of y and g of x. See, already we substitute capital F of y, right? In equation 3. In equation 3, just replace g of y is 0. That is z is equal to cos x plus cos x into cos y plus cos y. This is the required solution of PDE. See, in this solution we don't have constants because we already find the values of those constants. Similarly, fifth problem, dou square z by dou x square is equal to xy. So solve, find out z. Before finding z, find out dou z by dou x first. If we split this, we'll get like this. Dou by dou x of dou z by dou x is equal to xy. If we just integrate it once, we'll get dou z by dou x. This is equal to integration xy dx. So dou z by dou x is equal to x integration x square by 2y plus f of y constant. Consider dou z by dou x equation as 1. Similarly, integrate again, we will get consider that z equation as 2. Now find the constants, that is g f of y and g of y. Consider the given conditions in the problem. Conditions are dou z by dou x is equal to log of 1 plus y. This is when x equal to 1, and z equal to 0 when x equal to 0. Now by the data, dou z by dou x equal to log of 1 plus y when x is equal to 1. I am going to use this condition in equation 1, because in equation 1 only we have dou z by dou x. Okay, so replace in place of dou z by dou x log of 1 plus y, which is equal to x is 1, right? So 1 by 2y plus f of y. If we simplify this, we'll get f of y is the log of 1 plus y minus y by 2. Okay, just replace in f of y place. We will get equation 3. Okay, now by using equation 3, use the condition. Next condition is by data z equal to 0 when x is equal to 0. In equation 3, substitute all the values. Z0, LHS 0 is equal to x 0 means first term 0, second term 0 plus g of y. That's why which implies g of y is also equal to 0. We just substitute g of y in equation 3. So we'll get z is equal to x cube y by 6 plus x into log of 1 plus y minus y by 2. This is the required solution. Similarly, we can solve sixth problem. Here we have dou square z by dou x dou y equal to x by y. So first find out z. See, first split the derivative dou square z by dou y dou x as dou by dou y of dou z by dou x is equal to x by y. Before that, here first you should see the condition. Here they given condition for dou z by dou y. Sorry. You see here dou square z by dou x dou y here we have, but here they given condition for dou z by dou x. Suppose if we split this, what we'll get? See, suppose if we split this, we'll get dou by dou x of dou z by dou y, right? Dou z by dou y. Okay, suppose if we integrate first with respect to x. Suppose if I integrate with respect to x, derivative and integral gets cancelled. We'll get only dou z by dou y, right? But here the condition is for dou z by dou x. Okay, that's why here I am going to use this property. According to PDE, the property dou square z by dou x dou y is equal to dou square z by dou y dou x. Okay, by using this property, I am going to rewrite the given equation. Okay, if we rewrite this equation, we'll get dou square z by dou y dou x. We can write dou square z by dou x dou y as dou square z by dou y dou x. Now we can split like this. See, if we split, we'll get dou by dou y of dou z by dou x. If we integrate once, see, dou by dou y and integral gets cancelled, we'll get only dou z by dou x. See, here it is. So dou z by dou x is equal to x log y plus f of x. After integration, we'll get this. See, because first we have to integrate with respect to y. If we integrate with respect to y, x by y integration, x into 1 by y integration log y plus f of x. Now to eliminate dou by dou x, we should integrate with respect to x. See, to integrate with respect to x, if you integrate with respect to x, see, dou by dou x will eliminate. So x into, see, x log here, now log y is constant, x integration x square by 2 plus f of x, function of x. Now we are integrating with respect to x. So that's why this becomes capital F of x. Plus after the integration, constant is g of y. Okay, call this as equation 2. Now use the conditions. By using the conditions, we can find f of x and g of y values. So now consider first condition, that is dou z by dou x equal to log x. This is when y equal to 1. Okay, now by this condition, equation 1 becomes, in place of dou z by dou x, we can replace it by log x. See, log x is equal to, y is 1, right? So x, right, as it is, log y, log 1 plus f of x. Log 1 is 0. Log 1 value is 0. So we need f of x, no? F of x is equal to, see, this term is 0. Okay. That's why we'll get f of x is equal to log x. But we need capital F of x, right? So capital F of x is nothing but integration f of x dx. Just integrate this log x into 1. We can't integrate log x only, right? So log x into 1. Now integrate by using integration by parts. We'll get log x into x minus, here integration x into 1 by x gets cancelled, only 1. Integration of 1 is x. So x log x minus x. This is our capital F of x. Now substitute f of x in z. After substituting, we'll get equation 3. Now we should find out one more constant, that is g of y. To find that one, we use the another condition. That is z is equal to 0 when x is equal to 1. If you substitute these values in equation 3, we'll get g of y is equal to 1 minus 1 by 2 log y. Now you just replace in equation 3. Replace g of y by this value. We'll get the required solution. That is the required solution of PDE, non-homogeneous PDE. Okay. The next topic is solution of homogeneous PDE involving derivatives with respect to one independent variable. Okay. See, just now we discussed about non-homogeneous PDE by direct integration. Now we are going to discuss homogeneous PDE involving derivatives with respect to one independent variable. This is also a PDE, but there we have only one independent variable in that equation. See, there is a note for this. In a given PDE, if z is a function of single variable, then we can treat given PDE as ODE. See, we already know that. See, dy by, this is not PDE, this is ODE. Dy by dx. When we use dy by dx and when we use dou, dou z by dou x, when we use the dy by dx, means here when we have only single independent variable, we use ordinary derivative. When we have, see, if suppose z is a function of two variables, x comma y, here x and y are two independent variables. So here we should use partial derivatives. That's it, right? So in PDE also, suppose if you have only a single independent variable, we can treat that as ODE. Okay. So by using that concept, I am going to find solution of this PDE, means homogeneous PDE. Okay, na? By using that concept, it means ODE concept. The equation dou square z by dou x square plus z is equal to 0. In homogeneous, RHS should be equal to 0. Okay. See, z by here z is a function with respect to x only. We don't have y term, right? Here z is a function of one independent variable. So that's why now I'm going to write this PDE as ODE. Okay. So I will write PDE in term of ODE because we have here z is a function of single independent variable. Okay, na? So that's why we can rewrite dou in term of d. We'll get d square z by dx square plus z equal to 0. See, we already know how to solve ordinary differential equations, means homogeneous ODE. The solution of homogeneous ODE is complementary function. Complementary function is the solution of ODE. Right. So here also we should do the same thing, because now we converted homogeneous PDE in term of homogeneous ODE, right? That's why first we should find the solution in term of ODE only. Solution of ordinary differential equation homogeneous ODE is complementary function. How to find complementary function? First we should rewrite d square z by dx square plus z is equal to 0 in term of capital D. D square z by dx can be written as capital D plus 1 into z equal to 0. Okay, now write the auxiliary equation. It is m square plus 1 equal to 0. Roots are m equal to plus or minus I. For this, complementary function is the root are complex root c1 cos x plus c2 sin x. Okay, see, this is the solution of ODE. See, this is the solution of ODE. But we need solution of PDE, right? PDE means there we should have two functions. Okay, see, but we need solution of PDE. To get solution of PDE, we should replace C1 and C2 by functions of y, because C1, C2 in ODE, C1, C2 represents constant, no? Cos x, cos y represents functions. In Z we have cos x and sin x. Function of x we have. That's why we can treat C1 and C2 as functions of y in PDE. Okay, that's why we written Z is equal to f of y cos x plus g of y sin x. This is the required solution of PDE. Okay, this is the solution in term of PDE. Okay, now f of y and g of y are constant. Now by using the given condition, see the problem. See here we have some conditions, right? See here, x equal to 0. See, when x equal to 0, z equal to e power y and dou z by dou x is equal to 0. This means when x equal to 0, z equal to e power y, and also when x equal to 0, dou z by dou x is equal to 1. So by using these two conditions, we can find out f of y and g of y. Okay. See, this is called this as equation 1. Now use first condition. What is the first condition? X equal to 0, z equal to e power y, right? So here consider that condition. Now see, z equal to e power y. You replace z by e power y. This is equal to f of y, right, as it is. X 0 means cos 0 is 1 plus sin 0 is 0. Second term completely 0. So we'll get f of y is equal to e power y. Okay, now to say use second condition. What is the second condition? X equal to 0, dou z by dou x is equal to 1. Okay, so dou z by dou x is equal to 1. See, we have z only, right? We don't have dou z by dou x. We have only z. Now to use that condition, we should differentiate equation 1. Okay, to use that condition, we should differentiate equation 1 with respect to x. See, differentiate 1 with respect to x, then only we can use this condition. We'll get minus f of y cos x differentiation sin x plus g of y sin x differentiation cos x. Now use that condition. What is the condition? See, the condition x is 0, dou z by dou x 1. So dou z by dou x LHS 1 is equal to x is 0 means sin 0, 0, cos 0, 1. So we'll get g of y is 1. So now we got both the values f of y and g of y. So just replace f of y and g of y in equation 1. We'll get the required complete solution. So f of y is e power y, g of y is 1. That's why the solution is z is equal to e power y cos x plus sin x. Okay. This is the way of finding solution of homogeneous equation by converting into ODE. Okay, na? Similarly, we can solve second problem also. See, second problem, dou square z by dou y square equal to z. Here z is a function of y only. Okay, so that, see, we rewrite in term of ODE and find out the roots. We'll get plus or minus 1. Therefore, the solution is c1 e power y plus c2 e power minus y. So here we should consider the c1 and c2 as f of x and g of x, function of x. Function of x are the constant. Okay. So now consider z is equal to this. Call this as equation 1 now. Now as usual, find out, use the conditions. First condition, y equal to 0 when z is equal to e power x. Therefore, if you use this condition in equation 1, we'll get, see, z is e power x, no? That's why e power x is equal to f of x into 1 plus g of x into 1. E power 0 is 1, right? Anything power 0 is 1. So that's why e power 0 value is also 1. Then after simplification, we'll get this. C power x is equal to f of x plus g of x. See, here we didn't get any values, right? Any value means f of we did not get f of x or g of x. That's why you just call this as equation 2. After substitution, you just consider this as equation 2. Similarly, to use the second condition, means this condition, we need the derivative, right? To find the derivative, just differentiate 1 with respect to y again. You will get f of y into e power x minus g of x into e power minus y. Okay. Now use the condition, you will get f of x minus g of x is equal to e power minus 6. Equation 3. Now observe 2 and 3. If you observe 2 and 3, see, this is 2 and 3. Now see, if we solve 2 and 3, which means if you add 2 plus 3, we'll get f of x value. Similarly, if we subtract 2 and 3, we'll get g of x value. Okay. The f of x is, after simplification, we'll get cos hx. Similarly, g of x is sin hx. You just substitute in equation 1. This is the required solution. Similarly, third problem. It is here, z is a function of x only. Okay. After rewriting in term of ODE, we'll get d square plus 3d minus 4 into y equal to 0. As usual, find out the roots. We'll get 1 comma 4, minus 4. For ODE, solution for ODE is c1 e power x plus c2 e power minus 4x. But we need solution in term of PDE, right? See here, z is a function of x. That's why we can consider c1 and c2 as function of y. C f of y, g of y. Now, this is the solution in term of PDE. Now, by using the conditions, we can find out f of y and g of y. So that, see, we need, in conditions, we need dou z by dou x also, right? So we have z. So in this step only, you can find out dou z by dou x also. So you will get the derivative. Now, we can use the condition. First condition, z is equal to 1 when x is equal to 0. Use this condition in equation 1. So we will get f of y plus g of y is equal to 1. Similarly, second condition we can use in equation 2. That is dou z by dou x is equal to 1 when x is equal to 0. Then equation 2 becomes this. That's why we'll get f of y minus 4 g of y equal to 1. So now see, if we solve 3 and 4. Okay, by solving simultaneous method, if we solve, we'll get f of y is 1 by 5 into 4 plus 5. G of y is 1 by 5 into 1 minus y. This is the required solution. Similarly, we can find out fourth also, which is also similar to previous problem. See, dou square z by dou x square equal to a square z. Those are the conditions. See here the roots are m equal to plus or minus a, z equal to c1 e power ax plus c2 e power minus ax. The solution in term of PD is c1 c2 replaced by f of y and g of y. And now in this step only you can find out derivative also, z with respect to x. Now we can use the given conditions in equation 1 and 2. If we use, we'll get f of y as sin y by 2 and g of y as minus sin y by 2. Now you finally replace f of y and g of y values in equation 1 and then simplify like this. After simplification, we'll get sin y into sin h ax. Similarly, we can solve fifth and sixth problem also.